Hello guys, welcome to the new video. Today we are going to see the algorithm course. The topic to be covered in this lecture would be uh, lecture schedule is this, I think. Design and analysis of algorithms. Alright. First would be algorithm concept and life cycle. Analysis of algorithms, methodologies and types of analysis. This is important. Asymptotic notations, ASN. 2 3 question would be put from this, right? Framework for analysis, recursive algorithm, a priori analysis of recursive algorithm, analysis loops. This is important. Space complexity, mathematical background. Everything is important, I think, but some topics are more important. And then lecture schedule, divide and conquer. This is general method. These are things, quick short. These all things. Lecture schedule, greedy method, and this dynamic programming. These are topic LCS, MCP. These are the important problems, I think. These are applications and method of dynamic programming. This is important for 1 or 2 mark questions. Graph algorithms and all, right? And leftover topics will be sorting. This is sorting algorithm. Sorting algorithms are there. So prerequisites to this course is, what are the prerequisites? Programming, construct construct like less, if, then, else, loops compilation. These things should be, I think, these are prerequisite programming. Data structure should, you should familiar with data structure like stacks, queues, linked list, trees, and graphs. So this is important data structures. Right? Mathematics and functions, how our functions work, series, APG, PHP. These series are important. Matrix, right? Calculus, logarithmic, exponents, probability. These are some mathematical topics which is required in this, right? Algorithm is math plus logic. This is the algorithm theory altogether. What is the scope and outcomes of this course is we can give ISRO exam, NICT, bar, state level, university exam, UGNet, TIFL, placements, predict product-based companies, service-based. These companies ask the questions from algorithm, semester exams for subject knowledge, interviews. All these things are important, right? So, other courses, AI, machine learning, deep learning, all these things, algorithm is important, right? Deep learning, network, neural network. I think research. I think I don't know what is neural network. So, what is algorithm concept is consists of finite set of steps. What is algorithm? We can say. So this is a solution to a problem everywhere. Algorithm is a solution. Right? Algorithm a solution to a problem. Right? Always consists of finite set of steps. Wait a second. Yes, this will go. Algorithm consists of finite set of steps, statements to solve a given problem. Alright. So person, what is this? MD Musa Al-Khawarizmi came with the concept. I don't know how to use it. Every algorithm may take zero or more inputs. Every algorithm must produce at least one output. All right. It could zero take zero input or more inputs, but at least greater than one outputs always. Okay. All right. So consist of one or more fundamental operations, addition and assignment, def, uh, definite effective finite time. Recipe, I don't know what you are trying to say here, but statement consists of fundamental. Yeah, statements are consist of fundamental operations just like this statements, the addition, assignment. So the fundamental operations are statements. Algorithm, abstract machine learning, machine processing logic. Right? Input algorithm or machine formal output flow. Grain. This is the every algo should terminate in finite amount of time. Right? So this is also a concern with the developers. Every algorithm should what we say should terminate in finite amount of time. Alright, this is also a case. What is further is algorithm lifecycle step. Problem definition. First is problem definition. Problem lifecycle step. Problem definition. Requirements. I think conditions. SRS and logic design. Then develop algorithm. Express that. Validation. Prove correctness. Analysis of the algorithm. We will see this is an important part. Project design and this is an important part. Implementation, program development, and testing and debugging. This is a life cycle where DA, design and analysis of algorithms. DA, I think. SRS is a requirement and conditions. So we will see in this next lecture, I think. What So what is this next slide is need for analysis. Why analysis of algorithm? Why this is need? To determine resource consumption, alright? Because how much this is going to consume resources of our resources, time, space, registers, how much time it will take, how much space it will it requires, how much registers, what is the cost, and so on. Cost are different parameters of cost, PC domain, right? Performance comparison to find out efficient solution, right? Efficient, this problem time to take time t1, this t2, this algorithm take t3. So time is the efficient solution for algorithm, alright? These are all which is why we need analysis of algorithms, right? What is methodologies of analysis? How time complexity? So x plus x is equal to y plus z, alright? Single language, OS, hardware, alright? This is software, this is CPU. So three things are platform dependent: CPU, memory, and IO. Right? Software 0.5 nanosecond. Time complexity. A posterior analysis. A posterior. What is a posterior analysis? These are platform environments. All right. That things are depend on platform environment. A posterior analysis. What is this? So let's we search the what is a posterior analysis. A posterior, a posterior analysis. This is posterior and priori analysis. So let's see what is this is saying here. Let us slow now. What is the problem? So analysis prerequisite algorithm is a combination of sequence of finite. This is two factors: CPU time, main memory space, time velocity. A posterior analysis or posterior analysis is a relative analysis. It is dependent on language of compiler and type of hardware. Alright. It will give exact answer. Alright. So it will give you a exact answer. A posterior analysis. It does not use asymptotic notations to represent the time complexity on algorithms. Right. The time complexity on algorithm using the posterior posteriori analysis differ from system to system. Alright. If the taken time by program is less, then the credit will go to the compiler and hardware. It will done after execution of the algorithm. It is a costlier than the priori analysis because of the requirement of software and hardware of the execution. Maintenance phase is required to tune the algorithm. Right. What is the priori analysis? Priori analysis is absolute analysis, relative absolute. It is independent of language of compiler and types of hardware. It will give approximate answers. It will use asymptotic notations to represent how much machine. The time complexity of the algorithm using priori analysis is same every time. If the running time for all right. So we seen the how what is the post. I think what is going on here. We are doing things and always it's automatically put off from the internet. Internet is slow here. What do you say? Is internet slow or just we are being I think sarcastic, optimistic, fantastic, fucktastic, fucktastic. Wow. So oh wow. This return all the pages. So this is a very good sign I think. This is a very good sign to me at least that how it will going to work. All pages are back. We are happy. You are happy. I am happy. I think. So, what is this for? What is a posterior posterior a posterior analysis? This is platform dependent always. Hardware and software depend on hardware and software. It gives exact value in real units. Drawbacks of this and limitation: it is difficult to carry out manual work. Yes, cannot consider for all cases of inputs. Alright. Non-uniformity performance comparison becomes difficult because non-uniformity because vary from system to system. A priori analysis analytic framework take into account all phases, possible inputs, allow us to calculate the relative efficiency, performance of the two algorithms in a way that is independent of fluid form, can be carried out by studying the high level description of algorithm without actual implementation. It is easy to carry out. Yes. Drawbacks will not give the real actual value of in units, estimates and approximations. Alright. So let's say what is this says. Components of analytic framework. I think this is a language, for describing algorithm steps. Yeah, pseudo language. Steps should be described in a language. A computation model that the algorithm executes within it. A metric for measuring algo running time. A approach, a notation or characterizing running time. Yeah, notation we have associative notations to represent that. Right. Algorithm test. I think this is let's say this is an algorithm called test. And first statement x is by z, and this is a for loop a 1 to n, a to b to c, and this is another for loop, and this is another. There this is. Then let's say how much time it will take. First 1 unit time it will take for y plus z, alright, for addition, 1 unit time of CPU, and one for assignment. 2 unit time from here. Now for this, how much time it will take? First for initialization 1, alright, and how much from here is first initialization, then comparison, how many times it will compare? I think n plus 1 times, then this and this 2, n times this and n times this, right? One, I think one step I am missing. Where it is? I think incrementation. I think I am missing 1 and 2. 1 2 n plus n 2n is 1. So this is the one I think the approach for this. RAM model of computation 3i plus plus 3n. The one, so for one for assignment 1n, n plus 1 I think, one for incrementation. Alright. So no, this is for let's see. This is how it is well. One for assignment first, alright. Then one for n plus 1 for implementation. Let's say n. Then right, n for comparison, n for addition, and n for assignment. This is the time complexity of this units. I think units. I think how I say units. So yeah, for I goes to for this, 1 for this, and n plus 1 times this, and n times increment I. Each fundamental operation, basic operation, takes 1 unit time of time if this is our assumption. Right? So what is we are going to see that for this time and times this is all bullshit, I think. And to n times j, this is all these things are. What is the order of this time complexity then? This time is this time units. These time units are, this is the time units order. Order of some order of n square, representation the time, and input size, comparison, linear search. Thank you so much. We will meet you in the next lecture, or we can say next video. Take care and bye bye.